Okay, guys, can we start?
Yes.
Can you all turn on your camera if you can for a minute before we start? Hi, Sushant.
Hi. Good seeing you again.
We'll start at least when like 5 to 6 people turn on the camera. You can turn it off after a minute, that's fine. I can say Harshit. Hi bro, you're like in a 90s movie.
Hey. Yeah, the lighting isn't good in my room.
That's fine. So, doesn't matter. Just waiting for others. Because I just need to know am I actually speaking to people or just turned off cameras in laptop. I mean, I used to do that, so I can't blame anyone. Just wanted to see what's on that wall. What to do, bro? You want me to take a workshop when I leave from office, so I just came to nearby Chivas.
Yeah, who can teach better ROS, tell you?
Yeah. Who is it? Is it Aditya Rasan? Who is this in IEEE ROS channel? Yes, you will never know. It's Aditya. See, I have one cup chai. I'll aram se drink and sit. Till at least 4 people turn on, I'm not gonna start anything. I don't know about it, but last time it really helped people when they integrated ROS to their project because it simplified the process a lot during the hackathon. And Sushant, you were the one who participated alone, right? You messaged me. Okay. You can call me, bro. Don't message me. Just call me directly. That's fine.
Okay, sure.
So we are having tough people over here to break. So am I? It's I really don't want to call names.
Something started or it's starting now?
I'm just waiting for at least like 4 people to turn on their camera to start. I'm just waiting. You wanna join?
Okay.
Okay, one more then. As I said, you can turn it off after a minute, but yeah. I'll mute myself. We'll start once that happens. nice vibe, bro.
Okay, that's three.
Yeah, that's three. And I can do this all day. Let's wait for one more. Oh, at last. Nice, bro. Living your life. Okay, cool. Then we'll start. So, hi guys. This is Gokul Raj. If you don't know, like, I was leading IEEE RAS last year. So, right now, I'm just working on robotics as a career. So, I'm here to get you guys started with ROS. Before that, let me know in the chat box how many of you know ROS already. If you know, just put a +1. Like, at least the basics. Kaushik, it's such a nullified. So, anyone else? But, okay, how many of you heard of ROS? Come on, guys, you joined ROS Workshop, you should have heard of ROS. Anyways, hi, sorry. Okay, cool. First, my voice is clear, right? Before I continue.
Yeah, there's a slight disturbance. It's all right.
That I can't help. If it's audible, that's great.
Yeah, it is. No worry.
Yeah, cool then. So first, I'll start with like what is ROS. Before that, I want someone to interact with, like anyone who's ready to just have a conversation. So with that, we will start. It will be easy for you guys to understand. Anyone who wants to speak? Yeah, okay. What's up? How's life?
It's really nice.
Okay, cool.
Without
So,
Without sleep for the past 2 days.
why? What happened?
Assignments and tasks.
Okay, cool. So let me ask you a question. Imagine there is a. Okay, imagine like you want to make a. Do you know cooking?
Yeah,
What level?
mediocre.
Okay. So just a yeah. Cool.
Maggie.
Do you know to make? Yeah. Okay. Fine. Let's take Maggie only so everyone understand. What? Okay. If I ask you to make Maggie, what will you do?
Boil water, add the masala, later add the noodles and then cook it for more than 2 minutes.
Okay. So now, if I ask you to make one course meal, how will you cook?
What? Course meal.
One course meal like rice, gravy, blah blah blah.
Individually cook rice, separately cook the curry. Yeah.
Okay. So right now, if you take this example itself, so cooking is a task, and when you want to cook like one course meal, that is one task, which is divided into various subtasks, like doing rice, doing your gravy, doing your appetizer, whatever. And all of this will happen parallelly when you want the task to be completed. But each thing has to be done individually, and each thing has a set of tasks. For gravy, you need to put water, you need to put vegetables, you need to saute, blah blah blah. So this exact analogy, let's apply in technical sense, and that is what ROS is doing for you. There are multiple tasks done for a project, and all these tasks has to be done parallelly, and ROS helps you to get it done. For example, let's take a self-driving car. So when a car is driving, right, like you have to work on your acceleration, brake system. You have to see obstacle is there or not in road. You have to work on your multimedia system in the car, and all these things have to work immediately because you press a pause button in a song. That takes 1 second of your entire operation. In that 1 second, there's one kid crossing. It's boom. So each thing should run in a parallel track independently. So that is exactly what ROS offers you. With ROS, you can split your project into multiple parts and run all the parts parallelly and pass information from one part to other part. For example, like task A has some uh, five subtasks, and task B has some three subtasks, and task B will know what when task A completes each task. Task A will know when task B completes each task. So each and like everything will run as a system. That's the thing. Now let's take one real life example to explain the basic concepts of ROS. So Sushant,
Yeah,
what's the time now?
9:19.
Okay. So right now I asked him a question about time and he answered, right? So the question, like the topic, what we spoke about is basically time. And when I asked him a question, that means I am like it's basically I asked him, then he replied, right? So this is how ROS works. So it works on a major concept called publisher subscriber. So I can either listen or I can speak, or I can listen as well as I can speak. So this is what happens over there. Now there are multiple parts of ROS like topics, action, service, blah blah blah. We are gonna see simple thing. Let's take one simple project as an example. Um, okay. Can some of you like how is Robofest happening? Like, do you guys know the problem statement already?
No.
Okay.
No.
So, okay, tell me any one random project. I'll explain you how ROS will simplify it for you instead of a traditional.
Okay, taking my last project for Perfint.
What is that?
Yeah, building a line following robot using camera, and it detects obstacles, and it should also use ROS for moving around the path.
Okay, cool. So if you take this particular project, right, there's a mobile robot which follows the line, detects obstacle and avoids obstacle, and then goes to a particular location. Now this particular project can be split into three different parts. One part is line following, one part is obstacle avoidance. Let's just take this two for now. Let's going to a particular location, let's keep at the end. Now,
And one more, following Aruko markers.
that's fine. Let's just take this as an example. A line following robot avoids obstacle. Now you with ROS you can split this entire problem statement into two parts. One, a robot traveling the line, and one more is using ultrasonic sensor. It keeps on detecting an obstacle. So when it detects an obstacle, it publishes a topic called obstacle and saying yes, there is an obstacle. And this path following task is keep on following the path and subscribing to the obstacle topic. So whenever my obstacle part is publishing there is an obstacle, this path following part will stop the operation till the obstacle moves. Once the obstacle moves, my obstacle will send me like obstacle mode, so you can go. Then my robot will start moving. If you want to write this in one single code, like you have to do multi-threading, right? Because you have to check for obstacle at the same time, and you have to analyze the camera data at the same time and keep moving. So instead of complexing your like getting complexity in your problem, ROS helps you to divide it into multiple parts and do it. So did you guys get a basic idea why ROS is used and why ROS is used? If not, just say no, so I will give you a better analogy, because without understanding this, there's no point of going further. Bro, don't raise hands. No, I don't know, is it a doubt or right? Okay, you don't understand. Cool. If I'm pronouncing wrong, I'm sorry. Shruti, is it right? Can you unmute?
Yeah.
Yeah, hi. Okay, I'll give you, like, let's come up with a better example. Do task parallelly. Okay, cool. So let's okay, let's take cooking. Okay, like that only we will take. So when you want to make some gravy or something, like whatever, there's a dispenser, there's a stirrer. So stirrer will keep on sauteing things, and then dispenser will keep on dropping things. When dispenser drops, if stirrers keep on doing this, then the item may fall on the stirrer. So these two are separate tasks which just keep on happening. For example, so like I'm thinking of a better analogy. I'm just hearing the song over here. I can't think of. How to simplify it? Just a second. Okay, cool. This is better. So I'm taking the workshop, right?
Yeah.
Yeah. So I am doing I'm taking a workshop over here. I'm speaking to you guys, and also I'm seeing some text which is happening in WhatsApp. So this I am doing this two particular tasks parallelly, and this is so. If you want to, stupid. Why I'm so dumb today? Can't think of any analogy. Just
Are you looking for examples of multitasking?
it's so hard. Yeah. Do something for multitasking only.
Like you can like take a computer which is running multiple tabs, no?
I'm just trying to get some real life example, and my brain is stuck. Like, some reason. It's just stuck on the song which is going on in Chayos.
Okay, like you can think of like your condition right now, like you're listening to music, plus you're trying to think.
Yes, but something technical also. Okay, cool. Then I will just go with the line follower example only. So, Stuti, let's discuss this. Okay, what is a line follower? Tell me this. Let's get answer from you only. Can you please unmute and speak? Hi. Okay, fine. Anyone else? What does a line follower do?
Read the input and follow the line.
So what task it will be doing? It will be using its camera to read the line and it will be moving, right?
Yeah.
Now, if it detects an obstacle avoidance part, if it detects an obstacle, it needs to stop. If you want to make it in one code, what will be your approach?
I'll have two functions, one for following the line, one for measuring distance if there's an obstacle in front.
Okay, but the camera is running every time, like there's no delay, the camera is running parallelly, and also your ultrasonic sensor is running parallelly. So how will you make it work parallel? Because when you write two functions, you have to call one after other, right?
Yeah.
What if there is one obstacle coming on the way of the robot, the time the camera function is running?
Okay, that's a good point. I have no idea.
It will hit.
Yeah, it will hit, yeah, of course.
So to make the task foolproof, both should be running at all the time. And this is hard to do with standard coding we used to do, like one long code with multiple functions and stuff like that. So that is why multi-threading is used to run two processes parallelly, and that is what ROS offers. So basically, for example, imagine I am following that path. So I will keep on following that path. I'm Sushant. You are my obstacle. There are two codes. Gokul is a code, Sushant is a code. My work is I will just follow the line. I will look at the line, I keep walking. And Sushant's only work is to look at the ultrasonic sensor, like look at the obstacle and then tell me when there's obstacle or not. So we both will be working together. When Sushant finds an obstacle, he will tell me, Gokul, there's obstacle, stop. So I will stop. And then when obstacle is not there, Sushant will tell me there's no obstacle, go. Then I will go. So it's basically multiple codes running parallelly and passing information to each other so that they can do their task properly. This is what ROS does. It will run multiple code parallelly and enable them to transfer information between each other to make the process smoother. Did you guys understand?
Yeah.
Yes.
Now is it better? Okay,
Yeah.
back on track, I guess. It's been a long time teaching. Okay, cool. So let's start it. How many of you have Ubuntu? Just tell me that.
With ROS installed, yeah.
No, just Ubuntu. First,
Just Ubuntu, yes, I do.
yeah. Okay, let's ask this question. How many of you don't have Ubuntu?
Me.
Just write no in this.
I could take now, but it probably take time installing of the years.
Okay, so this is the
I can
question I
get
should
it
have
ready,
asked.
let's say give it time.
I think that is fine if you don't have. Okay, how many of you, just tell me frankly, okay, so that I will know how to teach here. Do you guys want to learn ROS just for Robofest, or you really want to learn this for robotics, you want to have it as a career or whatever. If Robofest, just get R.
Honestly, it's just my first time hearing about it, so I'm not even sure.
Okay. How many of you here have worked on some robotic projects before?
I worked on these things like if someone passes by, so you're supposed to like close the door, like turn on the light or switch off the light.
Okay.
That's pretty much all that I've done. That also was
Okay.
in school. After that, I've never
Okay.
done it. Yeah.
Okay. Okay. So cool. Then what I can do is you for if you are just using for the competition, you can just download VirtualBox. And do you guys know what VirtualBox is? No?
Yeah, yeah.
Yeah. So if you don't know what's VirtualBox, can you just text no? So I'll just give a quick intro of what VirtualBox is. Okay, Pranav, VirtualBox is something which it's a software you install in Windows, and inside VirtualBox you can have one more OS running. So you instead of dual booting your system, you can run Ubuntu inside VirtualBox itself in your Windows system itself. I will share you links of how to install VirtualBox, how to install Ubuntu, in that how to install ROS, everything, and also I will give you like I just made a document. Can you guys see the screen?
Yeah.
Yeah, so I just made this document. So here you can see how to install Ubuntu. I'll add a VirtualBox link over here. And this command you just copy paste to install ROS. This is if you just go to ROS wiki. Here also you can find all the details. Like first you have to ROS installation. Just go to ROS installation. Here you can find which version of Ubuntu you have. Like if you have 18.04, you should download Melodic. If you have 20.04, you should download Noetic. So just click on whichever version you have. Click on Ubuntu, and you can just copy paste all these commands one by one. And that's what I simplified and just wrote, and also all the dependencies which you will be needing. So this document I'll send, they will help you install ROS. Cool. So now we are gonna do okay, first I'll tell you what I will cover in this workshop. Okay. Instead of telling, I will just show you. This is what we'll be doing at the end of the workshop.
Oh man, I'm just curious. Where are you sitting? Like, the background was very interesting.
What?
Where are you sitting? Like, I'm just
Chayos,
curious.
Chayos, HSR layout. Can you just hear the background noise? Just a second. I will just show you. It's better if I show you what you are
Very
doing. So that,
interesting conversations going on in the background. So.
what?
Very interesting performance having in the background.
So this is what I'll be doing. You can see I'm controlling the robot with my mobile over here. Can you guys see?
Yeah, pretty cool.
So
Excuse me, is it the same commands for marketing?
yeah, no. Like you can just Control F, replace Melodic with Noetic, then it will be same.
No, I've installed it already, but this also a lot of stuff that you did.
Yeah, everything. Same. Like what I did here, you just leave it. I'll just explain to you what I did. So and also I will teach you using ROS how you can control your robot which you are doing with Arduino with the mobile app. So you, in your hackathon you can add it as an extra element to do the judges, whatever. Cool. Now we will proceed. Okay. First, I will be teaching you like what is publisher. Then I will teach you what is a subscriber. Now, tell me this thing. When you accelerate your bike, are you just giving acceleration once and leaving, or are you continuously giving the acceleration when you want to move?
Could you say that again?
When you want to ride a bike, the throttle you are continuously giving, or you just give it and just leave it.
Depends on where you're driving.
I'm saying a bike when you want to move.
Yeah, yes, of course, we turn it.
Of course, you will continuously give it, right? So basically, over there, like we can assume bike as a system, and what you are doing is you are continuously publishing the velocity, like the speed command to your system, so that your bike is keep on moving. Cool? Can we assume that?
Okay.
So this is exactly what publisher does. So a publisher is something which sends out the data. For example, right now I am speaking, that means I am publishing data to you. My name is Gokul, so that is my node name. In ROS, everything is ROS1, everything is a node, and what like every node will publishing a topic will publish data in something called as a topic. So right now this is a ROS workshop. I am a node, Gokul. I am teaching you ROS. So ROS is the topic, Gokul is the node, the data is what I'm speaking. Do you guys understand? Can you see the whiteboard? Just a second. Where is it? Yeah, can you see the screen?
Yeah.
Okay. I don't have mouse, so never mind. So I am Gokul. So this is node. I am a node, and I am teaching you ROS. And whatever I'm speaking, that is the data. So this is how everything works, and I am teaching to you guys. So let's say students. So yes, so you guys are my subscriber. I am publishing this data, and you are subscribing to this data, and then you are replying to me in a topic called answers. Like you are replying the answers to me, and what you are replying is the data. So in this entire conversation, there are two nodes: Gokul, students. So I am sending you data via topic ROS, and you are subscribing to the topic ROS, and then you are sending out your data via topic answer, and I am subscribing to your data. Do you understand what publisher subscriber is? Publisher is something which gives out, subscriber is something which takes in the data. Do you guys get it?
Yeah.
Okay, cool. Now let's just see a basic example. Basically, ROS code is a master. Like you need to run this before running any nodes in ROS1. So this kind of handles all the communication. You don't need to know the commands. I'm just trying to explain you the topics. Okay, over here if you see, in the right side you can see a robot, right?
Yes.
Right? Okay, over here I'm controlling it. Now let's actually see how ROS works. So this particular software is called Gazebo, and that is this Gazebo. This code which I'm running is called Teleoptwist keyboard. This basically sends out my velocity message to Gazebo. So over here, my this is a node, Gazebo is a node, and it is sending velocity using a message, using a topic called command will, and Gazebo is subscribing to the message and then reacting accordingly. You guys understood what publishing is, what subscribing is, how to do and all, let's see later, like the concept.
Yeah.
Now let's take the obstacle avoidance robot example only. Okay. So over there are two codes. First code is the code which follows the path. Second code is a code which is monitoring the obstacles. So this code is keep on following the path, and then this code is keep on watching for the obstacle. So this code, when it finds an obstacle, it publishes a message, let's say /obstacle, and this message is subscribed in this program, and the data which it is transmitting is true/false. It's a Boolean message. So when this code publishes true, this code will stop the operation. When this code publishes false, this code will continue the operation. So basically how the code structure will be, this code will be publishing and this code will be subscribing and then doing task according to the particular data. Do you understand like how it is used in actual project with the publisher subscriber?
Yeah.
Okay, now we will implement a very basic publisher subscriber and then we will dig deep down. I will show you where to copy the code for your project also. I will do it from scratch. I will copy, paste and everything, so it will be better for you. Just type ROS publisher Python. Now I'll explain you this. See, obviously I can't teach you everything in this particular time. I'll just teach you how to use ROS. So if you're interested, later you can just learn. pub.py, just copy pasting this. I'll first run this and then I will explain you what each and everything means. Okay. So this code is just a second. Yeah. List. Let it go still running. Close. You just click the screen here only so that I can show you. Okay, good. So now what is happening over here is when I run this code, you can see the data coming from that particular topic is hello world, and this is the timestamp. And when I stop this code, you can see the data stopped. When I run this code again, you can see that data keep on coming. Now I'll explain you what it is, then we'll do some modifications to this, and then we'll understand this better. So import ROS by basically standard, like importing the ROS libraries for Python. Now, okay, let's ROS like integer. Okay, let's just ask some questions and get answers. Can any of you just tell me quickly how to write a program for adding two numbers? Someone?
Python or ROS? Python.
Initialize
ROS
the
is not a
inputs to
language.
any data type and then give the a plus b command.
Okay, so you'll do like int a, like let's say C only, int a, int b, int c equals to a plus b, right? So over here, integer is a message. So but you don't need to explicitly get import int. Instead, what you will do, hash include studio.h or iostream.h, which will directly get all the files which are needed, which has this variable types stored and everything, right? But in ROS, it's not like that. Like if it's a string, you have to explicitly import it. If it's a float, you have to explicitly import it. And that is what over here. So from standard messages, so ROS has the standard messages, which is int, float, double, whatever. So from that, you are importing string. Now let's import integer, int 16. Okay, now we imported int 16 from the standard messages. Let's just remove all this unwanted stuff. Let's just do as simple as possible. Okay, now first I am declaring a publisher. So pub is a variable which will be my publisher. So as I explained you, over here Gokul is a publisher. So Gokul. So sorry, this is a topic. Let me. Gokul is a topic. Gokul is a node. And I am teaching you ROS in 16. Okay. Okay, so let's start with this. First of all, when I'm speaking, what is the main thing? I am there and I am speaking to you. So that's what you have to name each and every node. Over here, I am the node, so I'm just declaring Gokul, and this can be any random variable. A equals to rospy.publisher. You're just saying, it's storing it in a variable. You will publish a topic called as ROS, which is of type integer. Now, in 10 hertz frequency, it will keep on publishing. So it's a while loop, infinite loop. So let me, in the infinite loop, what I will do is I will just I equals to I plus 1, I equals to 0. So now my I will keep on incrementing. Now that is A dot publish I and rate dot sleep. So basically for 10 hertz, the while loop will, it's like a time dot sleep. It will wait, and then after 10 hertz, it will keep on moving. So what happens over here? You are defining a node called Gokul. He is publishing data in a topic called ROS. The data type is integer, and a dot publish, that is your publisher dot publish I. I is the data you are publishing. Now let me run this code. You can see ROS topic list, which will show all the topics. Basically, you can see here /ROS. Now let's see what ROS is. ROS topic. To see what is the data, it is ROS topic echo. You are echoing what is in that. Echo / what topic I need to echo, ROS. You can see the data keep on going. Now let's see RQT graph. RQT graph is a tool where you can visualize what is happening in ROS in a graph format. You can see /Gokul is a node. It is publishing a topic ROS, and this is my terminal basically, which is listening to it. You understood what publisher does?
Yes.
And how to write a publisher, like basic publisher. If you want to make it float, just do float here and change it to float here. If you want string, change it to string. So this is how you transfer basic data. Anyone, any doubt in this in writing a publisher?
No.
Okay, can I get some? Let's do Boolean only. If you understood, write 1 in the chat box. If you don't understand, write 0 in the chat box. So I will know, so that I will proceed. Bro, what will you do with the jam board? Oh, I only shared it. It is default. Okay. Can I get some 5-6 replies? so that I will proceed. I'm just going through very basics, like you will understand, Harshit, once we do it. I'm gonna repeat the same thing again and again because this is the first time you are hearing it, and these are the basics that need to be covered properly. Okay, cool. Now let's go to subscriber, and then we will do write some programs with publisher subscriber. Then we'll proceed to the next thing. Can you see the screen?
Yeah.
Okay. Now, just scrolling down, there's the subscriber code. I'm just copying it. So, okay. Now over here, I am publishing an integer topic, right? So I should also subscribe to an integer topic. So 16. Now let's start from, let me just remove all this. Okay. Now over here, again, each code should have a node. That is, each code should have a name. Local students. That's what we discussed. So let me just make it students over here. And now this anonymous equals to true. I'll just cool. Now rospay.subscriber. So this code, I'm declaring a publisher. In this code, I am declaring a subscriber. So to what topic I am subscribing? To ROS. What is the type? In 16. Now the data which is coming through this topic will be passed to this callback. Let me just make it A or B. Now define B and data. Now what I will do is I will print data. Print data. Okay. I will run this, then I will explain it to you again. Python p.py. Now wait. Oh, that's some different code. Graphics don't match. Why don't match? Is it in? Okay, it's float 32. Now you can see here. Now if I stop the publisher code, this also stops because publisher stops publishing. When I publish it again, you can see the data stream starts again. Now let's watch the RQT graph. RQT graph. Refresh. You can see here. Local is a node. Students is a node. ROS is the topic, and I am publishing to ROS. Students are subscribing to ROS. This is how publisher subscriber works. Now let's just go through the both of it again. First, this is a publisher code. I'm creating a node which is the name Gokul. Now let's take one more example and implement that. Okay. Now, okay, this will be my obstacle part of the line follower. Obstacle. Now this will publish a bool message. So it's a publisher. It will publish whether there is an object or not, which is a bool type. Now over here what I will do is I will just publish okay, wait. Let's just do something quick. I equals to I plus 1 if I mod 10 equals to 0, then a dot publish false. Else a dot publish, over here will publish true. Topic echo slash object. You can see over here. So every 10th data is like 10 false data you will get, and like 9 false data you will get, and 1 true data you will get. Now what I will do over here, in subscriber also, I'll subscribe to pool And then what is the topic? It is object. My node is, let's say, path following. This is rule. Going to this function. If data dot data equals to false, that means there's no obstacle. Print go forward. Else print stop. Now I'll run this code. Now we will see the RQT graph one more time and then we'll come back to the discussion. That is RQT. I will refresh. You can see obstacle, path, object is the topic, obstacle is publishing, path is subscribing to it. And this is what is happening over there in both codes. So this keep on publishing true, false, something like that. And according to the data it subscribes, it is giving the following commands. So now in publisher subscriber, any doubt?
Could you show example where two publishers are linked to one subscriber, how it works parallelly?
Oh, okay, cool. Right now, this is fine. Now what I will do, this pub.py is there, right? I will just save it as p1.py. And over here, I will do a different object. For example, camera, let's say. Camera. Camera is the node. It is publishing an image, and let's take integer maybe, because I don't want to I need to put 16. I don't want to complicate you with multiple messages, so let's assume it's publishing int messages. Okay, now what this code does, this code is publishing a topic image and it is publishing like 3 and 2 based on some random logic. Now in the subscriber, what I will do, I will also subscribe to one more topic. What is the topic name which we defined over here? Image. So I will subscribe to it, which is of type int 16. Int 16, which will go to C. So define C data, or you can just make it like J. I'm using random variable to show you that's not a keyword. Print J. Now let's run the subscriber. Now you can see it is just printing go forward and stop. Now I will run the second publisher, Python P1. Now you can see here, it is also printing this, it's also printing this. So now let's see RQT graph. You can see here, there are two topics, which is publishing data, and then path, which is subscribing to it. Now let's do something. What if the camera code also subscribe to the obstacle topic? So I have the subscriber code, I'll just copy the object part of it to my camera code. I will write a subscriber over here, and then where is this data? I'll explain you again so that it will be a little more clear. Yeah. Now let's see the architecture. So there are three codes running. Camera code is publishing image, path code is subscribing to it, obstacle code is publishing object, and path code also subscribing to obstacles object. So path is both publishing as well as subscribing. So do you guys understand this? Like how this works? So camera is basically publishing image as well as subscribing to object, whereas this two is doing one operation. So similarly, each program can publish n number of variables and also subscribe to n number of variables. Are you guys getting a basic idea? I'll go through the flow again. But yeah. Okay, cool. Now with the RQT graph on the left side, we'll just go through the code one by one. So first let's go to the obstacle node, which is the obstacle node. open pub.py. Yes. So this is my obstacle node. You can see a publisher over here, which is publishing in a topic called as object. Obstacle node, publishing in a topic called as object. Now this particular object can be subscribed by n number of nodes. So P1, this is my camera node, which is subscribing to my object. You can see a subscriber over here. Yes, camera is subscribing to my object, and also camera has a publisher. So camera is publishing image. Now my next code, subscriber code, is basically subscribing to my object. Yes, subscribing to the object, as well as it is subscribing to the image. So this has data from both these codes. So similarly, when you write a ROS code, no, there will be one main code where, like you can assume, and which will get data from all these independent subparts, and then will proceed in its operation. So this is how a project can be done with ROS. Like, is it fine? Are you guys getting it?
Yes.
How many of you know ROS serial? Did you guys attend the previous workshop? Sorry, by serial. Never mind. By serial.
Yes.
May I know how many of you know pi serial? Like, can you just type yes if you know pi serial? Only one person know what is a pi serial. Or if you don't know pi serial,